So, hello everyone, and welcome to this third session of Ask AuxEn Anything. So, this is an online platform for the civil structural engineers to interact with us and ask their problems related to some projects that they are doing, or in general, RCC or steel design, or for that matter, some construction or site issues also. So, this is the third episode of Ask AuxEn Anything. So I'll quickly start and I'll just share my screen and we will start with the list of queries that we have received. Okay. So let me just share the screen. So queries have been received through Google form and queries have also been received through email. A few of the queries have been received through WhatsApp messages, but WhatsApp messages we ask the people to put it on the Google form. So we'll just start now and let me start with the first query. So we'll take the queries first raised by the Google form or the participants who had mentioned their queries in the Google form. I'll start with that and then we will go to the queries received on email. So is my voice audible? Yeah. So you can see this. So till this session we start from this particular query and I guess till here we had covered in the last session. So from Mr. Narayan, 55 number. Okay. Till 54 we had covered in the last episode. So we start from 55. Mr. Narayan is asking how to calculate the spring constant for piles in CSI safe software. What is the type of footing to choose for pile cap, mat or footing? For columns, what to choose stiff? And can we validate the manual calculation? So I'll just put it all his queries over here and let us answer them one by one. Okay. Yeah. So let me just share. So how to calculate spring constant for pile in CSI software? So you generally, I mean, CSI software will not calculate the pile spring constant for you. You have to work it out. And from where do you get? So ideally, you should get it from the load settlement curve that is given for pile. Who gives the load settlement curve? So when you appoint a geotechnical testing agency, they will supposedly carry out an initial load test on the pile and from there you should get the load settlement curve. Okay, if you don't get, I mean, that is the most ideal scenario, that you will get the pile pile spring constant from the load settlement curve and it is plotted something like this. So you will have the load on one axis and this is the settlement, this is the load, and something of this sort your curve will be plotted. So you will be noting it down the load and the settlement, and in this manner you will get this curve. So usually the slope of this curve shall give you the load settlement at different sorry, the slope of this curve will give you the spring constant of this pile, because slope of this curve will be nothing but the load upon delta settlement, which is nothing but the spring constant of the pile. So this is the best way to get the pile spring constant from the load settlement curve, which is done for initial load test of piles. Now the problem is that initial load test of piles usually is done much after the project starts or much after the designing is started by the consultant. So maybe you don't have the load settlement curves for pile to begin with in the initial phases of your project. So what do you do then? In such a case, you will have to use some jugaad type of work. So from geotech report, you will get the approximate pile capacity. How will they give you the pile capacity? So they will be using the static formula given in IS 2911 part 1 section 2, I think. So from there you will get the uh, theoretical pile capacity based on the geotechnical data collected from site. Remember, this is not the actual pile capacity, it is a theoretical pile capacity. So let's say that that value is 600 tons, right? So you tested a pile, and this is the value that you got as the pile capacity as per IS 2911 part 1 section 2. Now what is the way to calculate a spring stiffness? So this is a jugaad type of method. It's not a I would say the ideal way to do it, but if in absence of data, because you don't have the initial load test results with you, this is a good jugaad that you can use for your day-to-day project work. Okay, so what do you say is that if the geotechnical testing agency is giving you a particular value as the pile capacity, then that means that they have followed the protocol of IS 2911 part 4. And what does that protocol say? So that protocol tells you that the pile capacity will be worked out in this manner, that I'm just going to show you now on screen. So I'm showing you the screenshot. I'm showing you the code 2911 part 4. So here it gives you how each of the test has to be carried out. So suppose my pile dia is less than 600 mm. So the safe vertical load on single pile for the initial load test shall be least of the following. Okay. So what does that mean is that I'll just maybe take a screenshot, and we will take it to our OneNote, and let me just share my screen over there. So what that effectively means, that this safe pile capacity is 6,600 tons that my geotechnical report gave me. That is basically the two-thirds of the final load at which the total displacement attains a value of 12 mm. So two-thirds of some final load is equal to 600 tons. Are you with me so far? So that means what must have been the final load? So you do 1.5 into 600, so 900 tons. And at this load, what was the settlement? Tell me. What was the settlement? So settlement was, as you can see from the codal provision, around 12 mm. That is how they had defined it. So at 900 ton, the settlement was 12 mm. So you can use this concept to find out the K, and then you can say K is equal to 900 into 10 kilonewton upon 12 mm, and then you can find it out in kilonewton per meter units. Is that clear? Okay, so this is the way you can work out the K value in case you don't have the actual load settlement curve for the pile. Okay, and how do you put it? So there is an option to put the spring constant, and you can use those options to put these values in the safe software. Similarly, you can work out the spring constant for lateral direction also as per the testing protocol that is given in IS 2911 part 4, in absence of any actual field test results available with you. So I hope this is clear. Okay. Then we move ahead. What is the type of footing to choose for pile cap, mat footing? Eh? What is the type of footing to choose for pile cap, mat or footing? Okay, I think he's saying in the safe which option to choose. You can choose any, it does not matter. It does not change the result. The results, the output results that you get are the same. So it does not matter. In safe, while assigning a pile cap, if you choose mat or footing or slab, whatever you choose, it does not matter in the final results. His third question is for column, what to choose stiff. Generally, the top of the column portion, the plan cross-sectional area of column is assigned as stiff. Usually people do it, so you can do that way. His fourth question is, can we validate the manual calculations? Yeah, you can validate. In fact, in our course on foundation design, we have validated these results what software gives us and what we get from manual calculations. In our course on foundation design, we have actually done that in a lot of detail. Of course, you may not be able to do it for maybe some raft like thing, because in rafts the moments will also be generated due to differential settlement. So maybe in raft, uh, cross verification with manual results may be difficult, but otherwise you can easily cross verify for your general isolated footings or eccentric footings. Even for normal pile caps, pile, you can cross verify the results with manual calculations. Okay. Mr. Vinayak is asking how to find the horizontal spring constant. The same manner as I explained, you will take if you don't have the load versus lateral displacement curve for the pile, then you use a jugaad. So you go to your geotechnical test report. They will give you a lateral load capacity of the pile. Suppose they have given you a lateral load capacity of your pile as 30 tons. Suppose. Okay. So this 30 tons is usually the pile capacity at a lateral deflection of 5 mm. That is what your code says. So if I were to show you the uh, IS 2911 part 1, IS 2911 part 4. So if you see in the lateral, where is it? Lateral load, section 8. The safe lateral load on pile, 50% of 50% of the final load at which total displacement increases to 12 mm, or final load at which the total displacement corresponds to 5 mm. Not yeah, in the first option it was 12 mm, second option it's saying 5 mm. So usually we try and limit the pile lateral deflection to around 5 mm. So let's say we got the 30 ton as our load or capacity from the geotechnical test report. So you just divide it by 5 mm and you will get the spring constant in kilonewton per meter units. Clear? Of course, I mean, you will do the unit conversion and you will get it. All right. Okay. Very good. So that was the first set of questions that were asked. Now I go to uh, the second set of questions that were asked. So Mr. Manish Parmar, he's from Dehradun and he's a postgraduate student. He is asking how to calculate the punching shear in flat slab at the vicinity of shear wall. So usually what happens, and if you are using SAFE, you will know this problem, that SAFE does not give you the punching shear stresses for shear walls, isn't it? How many of you know this? Nobody knows? Okay. So if you have modeled a shear wall and you want to get the punching shear in flat slab, how do you do it? What are the ways to do it? So first option can be that, let's say you had made a ETABS model, and for slabs, individual slabs, you are modeling it in SAFE. One of the ways can be that the model that is designated to be sent to SAFE, you model your shear walls as columns only, columns itself. That means instead of making it as shell wall, I mean modeling walls as shell elements, you model shear walls as column using the line element approach, and then bring that model to SAFE. When you do this, you will you will see that then SAFE will be able to calculate the punching shear quite okay for you, quite well for you. Now the problem in this such a case will be that in plan, let's say my shear wall was like this, and in shear wall we can divide shear walls in plan into different nodes also, correct? Now when we model a column in ETABS, what will happen? How many nodes it will have? How many nodes it will have? So it will have only one node. It will have only one node. So the problem in this case can be that, let's say your beam was, when it was an actual shear wall that you had modeled, maybe one of the beam was getting connected over here, other beam was getting connected over here. Now with column modeling, if you replace the shear wall model and replace it with a column frame element, the problem will be that it will only have a single node. So now when you want to connect this beam over here and this beam over here, how do you connect it? That is the problem. You understand? So in such a case, maybe you can use the concept of rigid links. Maybe you can use the concept of rigid links and model rigid links over here, which will help you to get over this issue. So this is one of the ways, although not very convenient way of doing it, but you may do it this way. What can be the other way? The other way can be that you check the shear stresses yourselves, and safe gives you the shear stresses. What does it name? S22. Hello. What does it name? S. Does someone recall what are the nomenclature used for shear stresses? I'm not able to quickly recall. Shear stress, what is the nomenclature that SAFE uses? So shear forces are shown by V13, V23. But if I want to see the shear stresses, okay, I'm not able to recall, but you can go to SAFE software, go to stresses, you check the shear stresses, and then you compare with the permissible punching shear stress that is given as 0 0.5 into under root 0.25 into under root FCK, and it has to be multiplied by some Ks constant, I remember, if I remember correctly. Okay, so you manually cross check the shear stresses and then compare it with these values, and then make a decision whether the punching shear is okay for this shear wall or not. So this can be one of the other ways to do it. A third way I think can be that no, third way, I don't know. Third way can be what? No, I'm not sure about the third way. You can follow these two ways right now. Okay. All right. Then Mr. Manish Parmar is asking discussion on concepts of annular raft. No, ask specific questions. What do you mean by concept of annular raft? Annular raft means generally in plan you will have a raft like this. So it will be a ring raft. Okay. In plan it will be a ring raft like this, and maybe now this annular raft you may have to give for columns which are placed like this on the periphery. Okay, so suppose you have some structure which has columns like this, peripheral columns. For this you may have to give annular rafts. Or you have a wall, you have a RCC wall, and top of RCC wall, let's say you have some structural arrangement for which that wall has been provided. So you may have to give. So this is my wall line I'm trying to draw. My drawing is not very good, but let's say it was a wall with some thickness. Oh, horrible drawing. You got my point, isn't it? So this was my wall. This was my raft, annular raft. And if I were to show you a cross section, how would my cross section look like? So my cross section would look something like this. Uh, let's say it was a case of a circumferential wall all around. So it will be something like this. Are you with me so far? What I'm saying? Okay. So this might be the situation. So this is my wall and this is my raft. Okay. So this is a typical arrangement how it looks for the annular raft. Now I'm not sure what your exact question about annular raft is. You have just mentioned discussion on concepts of annular raft. So concepts are nothing. You just have to take the loads coming from the superstructure. Accordingly, you can calculate the pressures below this annular raft. In oh sorry, my section was incorrect. My mistake. This annular raft may will be something like this. Clear? Because it's a circular. In between, there will be nothing. Are you with me so far? It's made up of two concentric circles with nothing in between. All right. So what are the concepts involved for annular raft? I mean, as such, there are no concepts. You just calculate the z of this. So you can calculate the z of this plan area. Once you have the z, you can quite easily calculate the p by a plus m by z. You calculate the pressures. You calculate the z of this cross section, and you calculate the maximum minimum pressure. Once you get the pressure, then you can calculate the shears, bendings, etc. Now, in this case, because in annular rafts, we will also usually provide a strap beam like this. That strap beam may be in the form of a wall or maybe in the form of an actual rigid element. What we are effectively able to do is that we are able to effectively have the bending of this annular raft only in one direction, that is the width, along the width of this raft. Okay, so it's we have converted this bending by providing a very stiff beam, strap beam, or call it a stiff wall. We have converted the bending of this annular raft into a one way behavior. So once you do that, then you can easily calculate the pressures, p by minus plus minus m by z, or you can calculate the shears, etc. Okay. So, because the question was not very specific, we just highlighted the meaning of annular raft over here. Mr. Sandeep is asking in general what questions can be asked from a 4.5 years experienced candidate having experience in steel and RCC design. I don't know. I mean, I have never asked questions. I don't believe in taking interviews. Interview is just a waste of time for the participant also, and for the person who is taking the interview, because you cannot judge anyone in such a short time. So I don't see any reason why people conduct interview. So he's saying in general what questions can be asked to 4.5 years experienced candidate, or what you would have asked to same candidate. So as I said, I don't believe in taking interviews. When we select participants, we just select them like that only, just by looking at them or having a general conversation with them. We try and select participants or candidates. We never conduct interviews because it does not carry any meaning. However, the questions that might be asked, you are saying to a 4.5 years experienced candidates, I think can be your usual questions about basics of RCC, steel design, okay, some basic conceptual questions. Then you can have codal, some questions checking the codal knowledge, maybe the basic steel codes, and then you can move on to your earthquake ductile design and detailing codes. Now we have got for a steel also. So maybe these types of questions. Some questions may be based on software applications, whether or not you are able to work on software. And people also tend to ask some bending moment diagram, shear force diagram type of questions. So maybe that also. I mean, if I had to appear for an interview, I would prepare it this way. But what do we ask when we take interviews? We ask nothing. We don't like to conduct interviews. So yeah, okay. So moving ahead, very good. Let me share my screen and let us go to the next question. So next question is asked by. Okay, so the earlier question was asked by Mr. Sandeep from Mumbai. He is a working professional. This question is asked by Mr. Rashid from Saudi Arabia. Abaha, he is also a working professional. He is asking, okay, I think he is from Kerala and working in KSA. So let us see what he is asking very quickly. I hope my voice is audible. Okay. So he's saying, what are the loads we need to consider while designing scaffold or formwork? Right. So for formwork, see all the expected loads you may have to consider. So one of them can obviously be the dead load. Okay. So dead load coming or dead load of the formwork system, dead load coming from the structure that is being supported by this formwork. Then you may have to incorporate some construction loads. So construction loads mean that, let's say this was a bridge deck that I was constructing in section. I'm showing this in section, and now I have to come up with a formwork system for this. Design a formwork system for this. So remember, this formwork system is a temporary system. So while designing, you have to keep that in account. So still, you will have to take some dead loads coming from this superstructure for which you are providing the formwork. Then you have to take construction loads. So in the period of this getting constructed, you may have to uh, put some equipments, construction equipments. People may be standing over here. So all those loads you may have to consider. Again, although it's a temporary structure, but these days your wind code and earthquake code require you to design your temporary structure as a scaffold also for wind and earthquake forces, whatever are applicable. So you may have to apply them also. So all these loads may have to be applied. If it's an exposed condition, temperature loads may also be required. So your general loads that you would otherwise use will also have to be used for such type of a formwork system. Okay. What all are the parameters need to consider? Up to what utility ratio? So parameters, if you mean to say the design parameters that we have to use for designing, while designing, your general effective length parameters or your general lateral torsional buckling parameters, all those parameters may have to be used. Okay. What utility ratio? So utility ratio should be kept less than 1. Load combinations will be general. Is there any code to follow? I'm not sure if there is any specific Indian code. I'm not very sure about it. But these days, if you look at the IS 875 Part 3, even if you look at the IS 1893 Part 1, you will see that in the scope itself, they write for the temporary structures also. So those are also included in the scope of IS 875 Part 3 wind code and IS 1893 Part 1 the earthquake code. So other than that, any specific Indian code or international national code for just the scaffold or formwork design, I am not aware. Okay, so this was Mr. Rashid from Kerala, who is right now working at the Kingdom of Saudi Arabia. Very good. Moving ahead, we go on to the next question. So this question is being asked, being asked by Mr. Shubham Kole. He's from Nashik and he is also a working professional. So what are his questions? Let us see. So I'll just take you. Uh, Wait a minute. If all the questions that are being asked on the YouTube comments, we will take them towards the end. Okay. Let me just first finish up the comments that the questions that were asked in the Google form. I'll just finish them up first. So Mr. Shubham Kole is asking when to consider earthquake in all the three directions and the load combinations as per IS 18. So it's quite clearly given under which scenario you have to consider which direction earthquake. You just go to the load combination. It is given in IS 1893 Part 1 also. So usually in IS 1893 Part 1 for non-orthogonal lateral load resisting systems, they ask you for that 30% combination. And for each direction of earthquake, they have told you how to combine them. 1893 Part 4 is for industrial structures. It also categorically tells you how to combine which particular earthquake direction in load combinations. Okay, so you just go to the code, it's quite clearly given over there. If you have any specific doubt relating it, you can come back and ask. Is speed delta analysis compulsory for every industrial structure? So right now, if you read IS 1893 Part 4, in a way they sort of mandate you to use the P delta, but P delta you may exercise some caution while using P delta, because please remember, if you are using E tabs and if you have turned on P delta, then automatically the sway effective length factor K is taken as 1 by E tabs. So it happens that in P delta your moments did not get magnified under the effect of lateral load, but your system was such that it had a very high stability index. Q was much greater than 0.04, meaning that your K value would be much greater than 1. But if you have turned on P delta in E tabs, automatically it takes the effective length factor as 1. So this can be a problem. So always be very careful if you are running the P delta analysis. Just check, double check what is the stability index Q that you are getting. Okay. Okay. Mr. Shobham is saying if the structure is of 3 floors, industrial process building, zone 3, do we need response spectrum analysis? Ideally, I shouldn't challenge the code. No, you can take a call yourself. Although the code says, I don't know what the code says. For industrial structure, what the code says? Is it compulsory? I'm not sure. But you can take a call if your stiffness and mass are uniformly distributed along the height. There is not much. Uh, there is not much. What did I want to say? There is not much irregularity in your structure, whether it is plan irregularity or horizontal irregularity or vertical irregularity, and the stiffness and the mass distribution is more or less uniform along the height, then I would say you may not consider response spectrum. But usually in industrial structures, what happens is that some mass may be concentrated at some story level, some other mass or some other equipment may be concentrated at a different story level. So usually you will not get you will not get the uh, uniform stiffness and mass distribution. So it is better actually to consider response spectrum analysis while doing a industrial structure where there is a high chance of irregularity. Okay. How should I create load combination? Load combination, just as you create with equivalent static, similarly you created with response spectrum. No need to create plus or minus with other loads. If you are doing it in ETABS, it will be able to take the signs on its own. So you just need to make sort of one combination. That is it. One combination means just add algebraically like this without considering any minus sign. Okay. So this was his set of questions. Let us move ahead. So now, uh, okay, before that, let me just take a couple of questions from YouTube also. Mr. Narayan is asking, how can you share the foundation course? You can go to our website, AuxEn.in, go to short-term courses, you will get it there. Mr. Magaj is saying why across wind is highly effective in tall buildings. It's not highly effective. You should have said why across wind response is highly critical in tall buildings. So the reason is because of the vortex shedding effect that takes place. You might get the across wind responses which may be governing, but remember that those are governing for slenderness ratio of your structure going beyond 13 or 14. I mean, more than 10, more than 11, then the across wind response becomes critical. Not for your usual tall buildings that you see these days, 40, 50 stories, and they have a good aspect ratio, plan aspect ratio. So their slenderness just comes to 7 or 8. There, the across wind response is not critical. Across wind response becomes critical when you get the slenderness ratio of your building more than 11, 12, not otherwise. And why is it effective? Why it is critical or why is it governing? Because of the vortex shedding effect, uh, especially for structures which are quite flexible in nature. Okay. Mr. Magaji is saying gross SBC versus net SBC. That is his next question. So gross SBC means where you add the pressure of overburden, and that is the value you consider. So suppose I have a gross SBC of maybe let's say 20 kilonewton per meter square at a height of 2.5 meters. That means that that gross SBC value will be inclusive of the overburden pressure. Okay. And net means without overburden pressure, that is the net value. That means, for example, uh, if any geotech report gives you the net SBC as 15 tons per square meter, that means that when you load the soil, it has the further capability to take another. I mean, it has the capability to take the overburden pressure over and above the net value. Okay. How to design stitch slabs in case of loose soil? I'm not sure what do you mean by stitch slab. Maybe you could elaborate. Mr. Magaj is saying, while designing flat slab, do we need to export floor loads only or floor and loads from above? So if you are designing just the one slab, taking it from ETABS to safe, you can use the simple floor loads only option. How to consider design eccentricity as per the code? So softwares are capable of taking the design eccentricity, which is the 5% thing. The only problem I think in ETABS, if I remember correctly, is that in case of response spectrum, I think it is not able to take the eccentricity. Especially, it does not take the dynamic amplification factor of 1.5. No, so it takes the eccentricity, but it does not take the dynamic amplification factor of 1.5. Otherwise, the code is capable of taking the design, not the code, the software is capable of taking the design eccentricity on its own. In ETABS, do we need to change effective length factor for ETABS calculation? I have seen two different consultant in which one is using. So effective length factors will depend on the sway, the stability index values that you are getting. It will also depend on whether you are designing your frame as an ordinary frame or a non-sway frame or a sway frame. So as per that, you need to decide. We have done this discussion in one of our earlier YouTube series. You go to YouTube channel and you go to project discussion series on our channel and watch the episode 1. Over there we have discussed this issue in great detail. You can have a look over there. Mr. Vinayak is saying how to find the time period for steel structures. It depends on what type of steel structure it is. So, I mean, you can use the software to find the time period for you. And there are processes. I think you will find it on YouTube. How to suppose you are using STAD, how to get the time period from STAD. If you are using ETABS is able to give you the time period directly. But if you are using STAD for your model, you can watch any good YouTube video which tells you what is the process to use to find out the time period in STAD. Okay. Okay. So these were few of the questions on the comments. Let us go back to the questions asked on the in the Google form. So next question is from, who is it? Next question is from Mr. Praveen Raj. He is from Salem. He is also a working professional. He is asking, while providing bracings for steel columns, some designers tend to provide bracings above the crane level only in intermediate columns. Below crane level, X bracings or portal bracings are not provided. Is this a good practice? No, it's not a good practice actually. You should provide bracings in elevation along the length of the shed, also at the locations where you have got the crane uh, bracket. Okay, that means suppose if I were to show you a picture, not picture, if I were to show you a sketch, and let me show you an internal elevation of your steel frame. So let us say these are the columns. I'm showing you an elevation. These are the columns. The top is, let's say, any roofing system. This green color was here. This green rectangle that you see are the crane brackets being taken from the column, and then this green horizontal lines is, let's say, the position where you have put the gantry girder. Now his question is, Mr. Praveen Raj, that should we provide bracing over here or here? So typically, if you ask me, it is better to provide bracings at the or below the crane gantry level. Okay, so below the crane gantry, you should provide bracings like this. You may provide alternate bracings, or you may provide bracings at the gables, at the ends, and maybe a few bracings after every one or two spans along the length of the shed also. But if you ask me, the effectiveness of this blue colored bracing will be more than this bracing which you provide over here at the top. Okay, so this bracing is more effective, and you provide one at the start and the end point, and then along the length of the shed, others you can distribute maybe after every one or two spans. Okay. Okay, so this was Mr. Praveen Raj. Now we go to the next question. Next question is being asked by, let me see who's asking. So Mr. Saif Ahmed, he is joining from Guwahati. He is a working professional. He had shared one image, so I will like to show you that image on screen first, and then we will take up his question. He had asked a specific query related to a safe model where he was getting some very high reinforcement concentration, and he was asking what to do in such cases. So you should always remember that SAFE is a 3D finite element software. So you may get some local maximas which might look very abrupt to you. So you have to be careful while using those results for actual design. So can you see this image? What he had shared? So here he is saying that he is getting suddenly a very high value, some 42,000 mm square per meter requirement of steel. Now this is quite high. In such a case, you may have to do some averaging on your own. Okay, so maybe you can make a strip over here. All right, make a strip over here. How much wide that strip be, that will depend on the I mean, there I don't have a straightforward answer for this, but the width of strip can depend by having a look at the what type of structure it is, what are the moment contours you are getting. So you can accordingly decide the width of this strip. Once you decide this width of the strip, you can construct that strip, and then the safe will give you a value of AST for this entire strip width, and here it will do the averaging on its own. So I think instead of directly relying on a FEM based output, it may be better to uh, use the strip based approach where the internal averaging will be done by the safe software. Okay, and how to decide the strip width, that will usually depend on the type of structure that you are having. So you will have to take a judgment call on the basis of uh, the moment contours. You will be able to make a judgment that what shall be your strip width. Okay. Okay, then let us quickly go on to the next question. If others are having question, they may ask. Mr. Anil Kumar from Pune, he is a working professional. He is asking how to decide which beam top flush to sunk slab top and provision of sleeves. So we had discussed a lot of things about the sleeves in the last session. In the last session of this Ask AuxEn Anything, how to decide the position of sleeves, and we had spent some 10-12 minutes discussing sleeves. So you may have a look at that session. But then your next question is, wait a minute. Your next question is that how to decide which beam will be at the top of your sunk. Now that will depend on the type of framing. He is asking how to decide which beam top flush to sunk slab top Okay. So he's saying, suppose you had a plan over here like this. I'm showing you a plan view. Maybe this is a column, this is a column, this is a column, and then I had beam framing. I hope you can see this. So this is my beam framing, let's say. And now here I have provided a sunk. So this is my sunk. Okay. Now how to decide which beam to keep at top? That means this top and the sunk. If I were to draw this section, whether my beam in green color, whether it will be above the sunk or below the sunk, how to decide that? Okay. So let's say this is my sunk, whether this beam is at the bottom or I flush it, my top is flushed with the top of sunk. How to decide that? So that usually decided by the positioning of your framing and also the way in which you want to provide your plumbing arrangements. So suppose you had to take out plumbings from here, okay, and you want to avoid making sleeves. So in this case, what you can do, that this beam top, then you can keep like this, so that you are easily able to take the plumbing lines from here and you don't have to cut sleeves. You got my point? And then we can take this beam top matching with the top of sunk like this. So I can have these two beams positioned like this. Okay. So here I have provided my sunk, and the sunk top and the beam top is flushing with each other. Clear? Hello. So it depends on the way in which you are going to take your plumbing lines. As far as possible, we usually try to avoid taking the sleeves through the beam. So this can be a good approach. And related to your question on where sleeves should be provided, you just go back and see one of the last episode, not one of the second episode that we did for Ask AuxEn Anything. There we have tried to answer to your query. Okay. Okay. Now, next question is from Mr. Arvind. What he is asking, he has shared a couple of documents. So I'll just put it in the group first. Not in the group, I mean in the OneNote I'll put it. It is a screenshot from some book. And then he has shared the PDF of the book, which I'm not going to show you. So his question is how to decide just a minute. Mr. Arvind from Chennai is asking, when designing a beam as a singly or doubly reinforced, we check for ductility and ensure that the beam is under reinforced. Also, we do an additional check for singly reinforced beam where we check the strain in steel and we check whether the section is tension controlled or not. So that is almost saying that that is the check for under reinforced, over reinforced. So what is this question? Then why do we design a beam as singly reinforced beam for ductility, even though ductility can be ensured in a doubly reinforced beam? I'm not very sure what he's trying to ask. Uh, what he's saying. Let me just see once again. He's saying when designing of this, we check for ductility and ensure that the beam is under reinforced. Okay. Basically, his question seems to be Why do we design a beam as singly reinforced beam for ductility, even though ductility can be ensured in a doubly reinforced beam? I think, see, why do not we like to have a doubly reinforced beam in our design? The basic reason is that in doubly reinforced cross sections, what has happened that on the tension side, I'm assuming a case where the sagging moment was causing a section to be doubly reinforced. So in my tension side, already my tension steel has reached the limiting tensile stress level. Okay, and my compression side, concrete has also reached its limiting compressive stress level. Now my concrete, okay, so if I wanted to increase the moment carrying capacity of this beam beyond this point without increasing the depth and width of this beam, what do I need to do? What do I need to do? I need to add more steel. Okay, how do I add more steel? So I add more steel over here on the tension side. Now only adding the steel on tension side may not be enough, may not be sufficient. Why? Because concrete over here has already failed, and it not failed, it is already at its upper level, at the highest level it can be. So now what I have to do is I have to add additional compressive steel, and this I say is my total tension steel. So in this way, by adding additional steel, we have tried to increase the moment carrying capacity of our beam. Now, why this is not a good approach if we want to use the ductile ductility principles? Because if you see, the concrete has already reached its maximum compressive stress levels. Now in our ductility, what happens that we also depend on what is called as the, or we also take into account what is called as the over strength factor. So over strength factor means we were assuming that my steel will yield at Fy. Accordingly, uh, it will take some corresponding stresses, but actually the steel can take up to a higher stress value of 1.2 Fy also beyond, that is called as the elastic, no, what is it called, post yielding behavior maybe. So beyond Fy, your steel can continue to take stresses and it can reach a value of 1.25 Fy. Okay. So now what will happen that if my beam is already doubly reinforced and I have put so much steel over here, and then it can take 1.2 Fy, 1.25 Fy. Now my steel over here will be under a problem. Okay. And my concrete gets stressed in that case. Now, because it was doubly reinforced, my concrete cannot take anything beyond this. So, if my concrete cross section cannot take anything beyond this, it will undergo failure, and that failure will be without any warning. It will be a brittle failure because concrete, when it fails in compression, it is sort of a brittle failure. So, that is why technically we don't like to have doubly reinforced cross sections for our beams, at least when we are using it as part of lateral load resisting systems. We will try and avoid them. Okay. Okay. So then we move on to next question. Mr. Next question is by Mr. Alek Katuwal. He is from Nepal. He is saying in many of my models having basement, I am unable to achieve 65% mass participation in third mode. No, you don't have to achieve in. One thing you should understand that you have to add up the masses in not in the first three modes per se, but you have to add masses in the first three fundamental modes. That means, let's say your model time period was. Can I show you something over here? Okay, I don't have it. So maybe your first mode was a translational mode in X. Okay, your second mode, suppose it was some translational mode in Y, Your third mode was some rotational mode in about Z. Your fourth mode was some translational mode in X again. Mode 5 was some translation mode in Y again. So when I have to add the masses, I don't have to add for 1 plus 2 plus 3. I have to add for the first three modes where the mass participation is happening in X direction. So I'll add the mass corresponding to first, fourth, and maybe seventh. Do you understand? Similarly, when I have to add masses for checking the Y direction, maybe I have to add this masses of second, fifth, and eighth. I don't have to add for the first three. It's not first three numerically in the sequential numbers. It is the first three in the modes where there is a significant mass contribution. Do you understand this point? Okay. So you have to add up like that. That was the first point. The second point was, what was the second part of his question? Second part of his question is that in his many models having basements, he is unable to achieve this. So if you are not able, see in your initial modes, even if you achieve somewhere around 60% of mass in your fundamental modes, it is good enough. It is good enough. Do you get it? You don't have to aim for 80, 90, 100% in your initial fundamental translational modes. Even if you are getting some 60%, close to 60% mass in your initial fundamental translational modes, that is good enough. And then, of course, you can use the response spectrum method. Now, why are you not able to achieve this? I don't have a ready answer. That depends on the model. That depends on what type of structural system you have provided. It depends on a lot of issues. So I cannot answer without seeing it. But once when I was seeing your model, I had given some suggestions that you can adopt. Okay. So maybe adding more walls, more shear walls, distributing them near the periphery, adding some L-shaped walls in the plan, or removing the central cores and replacing it with some brick, with some column beam framing. These can be some of the ways to do it. Okay, but I don't have a ready answer. Is my voice audible? I think something has hung up. Can you hear me and see me clearly? Yes, please. Okay. Mr. Regine is asking how to post doubts. So for doubts, we usually circulate our Google form. You can post your doubts over there, or you can type in live in the comments over here. We'll take them up. Let me just first take up the doubts that have been put on the Google form. Then I will take the other doubts. Okay. So next doubt is by Mr. Devlin. Devlin is from Muscat, Oman. He is a working professional. His question is regarding the column reduction at various levels. Let me just paste it in the. This is an interesting question, so just see what he's asking. He's asking, his question is regarding the column reduction in various levels. In some drawings, we find the below column width to be 500 mm. Okay. So he is basically asking about the detail that may have to be used when you are going to face a column reduction at successive floors. And then he had also shared one drawing. So what I will do is I'll just open the drawing for you and we'll see what he's asking. Okay. Yeah. Just give me a minute. Yeah. Anyone has any questions? Okay, I'll just take a couple of questions from here. Mr. Rajin Yael is asking what is the use of live load reduction factor. As I had explained in the last Ask AuxEn Anything session also, live load reduction factors take into account the possibility where all your floors will not be successively or simultaneously loaded with the highest design live load intensity. That means, let's say you have a 40-story building and you are designing the floors for 4 kilonewton per meter square live load. So the probability that all the floors together uh, will be loaded with the same intensity of 4 kilonewton per meter square is very, very low. So if that probability is very, very low, you don't need to design the columns, or you may not want to design the footings for the full intensity live load. And therefore, you may want to do the live load reduction. So that is the conceptual understanding of live load reduction. You can refer to IS 875 part 2 for the live load reduction calculations, live load reduction factor calculations. So basically for each floor, you multiply it by some factor and then you get the uh, and then you sum all of them up at every floor to get the final live load for your footing design or column design. Okay. Mr. Vinayak is asking, while designing the raft foundation, the raft is surrounding the lift. The raft surrounding the lift will be down, means we should fold the raft. Okay, so he is saying, okay, what Mr. Vinayak is asking is, yeah. So Mr. Vinayak is asking that generally what happens that sometimes, let us say you were providing a raft, just see over here. So I was providing my raft. This was my raft top level. Now suddenly what happens? There is a lift that I have to accommodate in the raft itself. Now this is 1.5 meters. Now what do I do? How do I manage my raft? So one thing is that whatever thickness you are getting over here, usually try and provide the same thickness all around this. So when you are folding the raft, ensure that you are getting the same thickness. This is number one point that we usually try and do. Second is, while you are providing PCC below this, so we will usually do PCC something like this. Okay. So in this region, we will do the PCC. This angle will try and maintain somewhere around 45 degree. Very clear? So something like this will be the PCC line. And while folding the raft, we will ensure that the raft is folded by the same thickness over here also. So the fold should be like this. Understood? So this is what we usually try and do. And of course, if things are quite critical, if there is a lot of lateral pressure that is expected over here, maybe, although for such a small thing it's not, but if it is expected, then you will have to accordingly check whether this much thickness is sufficient or you may have to provide more. But usually doing this, that means folding the same raft like this, maintaining the same thickness is sufficient usually. All right. Okay. Seismic zone 3G plus 7. What does it? Seismic zone 3. Acha, seismic zone is 3G plus 7. Now again, as I have repeated, it depends on whether you have what type of mass distribution and stiffness distribution you have. You can have a look at the model vibrations and model time periods that you are getting, and then you should decide whether you need to go for response factor or not. Okay. Mr. Magaji is saying, what is the impact factor to be taken for machine vibrations on first floor of RCC slab? It has to depend on the type of machine and what is the dynamic load expected. So there can be some impact type machines, there can be rotating machines, there can be different types of machines producing different types of dynamic behavior. So depending on the specific machine, you have to decide. I don't know about any thumb rule for that. Okay. 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 So let us continue and then take the question Mr. Devlin was asking, and we shall go to the AutoCAD drawing he has shared. Let us see what he says. So in this drawing, what he is saying is that there are column reductions happening between successive floors. Yeah, I guess this is the image that he wanted us to see. Can you see this image? So at the lower floors, the column is 500 by 1800. At the upper floor, the column is going to be 400 by 1800. So how to take these columns? So now see, you have to understand first of all from which side the column is going to be reduced. Okay, first of all, that needs to be understood. So that means sometimes you may, how do I write it? Wait a minute. Sometimes you may be, I think I'll just take this image to OneNote. It will be more convenient over there. Instead of writing it over here, I guess if we take that and do it in OneNote, it will be much more comfortable. Just a minute. Yeah. So see now how to decide about the curtailment. First of all, it depends on what is the way in which you are going to curtail. So maybe assuming you are going to curtail the column like this. Do you understand? So below it was 500 and now it becomes 400 like this. Okay. So what will happen? That these bars will have a direct face. I mean, these bars can continue straight. You get my point? Please understand. So this bar can go as it is to the upper level. This bar goes as it is to upper level. There are a few bars that are curtailed. So for example, this bar is curtailed over here. No bar goes up. But otherwise, these bars are okay. Now what happens with these bars? So you want to introduce these set of new bars, these bars, and this bar. I guess it's going up as it is. I don't see any problem over here also. No, there is a problem over here also. No, I think it's matching. It is matching with this and this is matching with this and this. The problem is for these bars. These bars are a problem. Now what happens in such a case? Your code SP34 tells you that what type of bar slope you can maintain. So for example, that means that let's say this was my face of 500 column, this is the 400 column, and this is the 500 column below. I'm trying to show you a sectional elevation. So those bars which were on the face which was not getting curtailed, they can easily go up. I don't have to worry about it. As it is, they are going up. Now for the bars which are on over here, you have to check whether you can take these bars and continue like this, providing that this slope is not steeper than 1 is to 6. This slope, I think 1 is to 6 will be like this. This steep slope, when you want to take, shall not be steeper than 1 in 6. Is that clear? If it is steeper than 1 in 6, you are not allowed to take the same bar. Are you with me so far? Okay. Yeah. And I think it is 1 horizontal to 6 vertical. 1 horizontal to 6 vertical. Yeah. So if this slope is steeper than 1 in 6, you are not allowed to use the same bar and take it like this. If you are not allowed to take the same bar like this because of the slope conditions, where is this slope condition given in SP34? So what do you do then? In such a case, you can just curtail the bar of the below column by providing development length. So beyond this face, or let's say beyond this face, just ensure that adequate LD is provided. terminate this bar, and taking the new bar for the 400 size column which was above, we just take a bar and start a bar and ensure that LD is provided. Clear? Is this clear? Yeah. So this is what you can do. So this is what we generally do in case this 1:6 slope requirement is not met. We will terminate the column bar coming from the below column and start a new bar over here. Okay. So I hope the query is answered. Now moving on to next question. So next question is asked by, who is asking? Okay, next question is being asked by Mr. Sandeep from Mumbai. He's a working professional. He's saying what is the difference between linear and non-linear static analysis. So linear analysis means where the geometry and material properties are considered to be linear. Okay, so geometry is also linear. That means there is no plastic strains or plastic, yeah, there is no plastic strains that we are going to consider. Also, we are not going to consider any material nonlinearity. That means my material will have a uniform stress strain curve within the range of stresses where we are doing the analysis. When I talk about nonlinear, that nonlinear may be due to geometric nonlinearity, and it may also be due to the material nonlinearity. Okay, so that is what I would mean by linear and nonlinear analysis. Now he's asking linear and nonlinear response spectrum analysis. I'm not sure. Linear response spectrum analysis generally means that we do not consider any material nonlinearity. We just consider the different modes and use it in our earthquake load calculation. Nonlinear response spectrum analysis, I don't know. Then Mr. Sandeep is asking, what he is asking? Thumb rules for design of RCC structure element. I mean, I cannot give thumb rules in one line. It has to the thumb rules vary from structure to structure, building to building, case to case. So I cannot have a one line answer for this thumb rules. So I mean, I don't know what exactly to answer over here. Okay. Then what was the next question? So Mr. Regin has put his questions over here. I think I have already answered. So use of live load reduction factor, I just answered. If building is located in zone 3 or 4, I just answered. When should you do the uh, when you should do the response spectrum analysis? Okay. I think you should read some basics of response spectrum analysis. Then we might have a better discussion. Okay. If you can see the model behavior, and if in your fundamental modes you see more than 90% mass participating, I would say that you don't need to do any response spectrum analysis. It would be good enough for you to do just to equivalent static also. But again, it will depend on the type of structure that you are having. Mr. Vinayak is asking, raft foundation around the lift we should fold at distance D. Can you just explain about pressure, punching, and steel detailing? Okay, so I think he is asking about the same question over here. So I had said that you maintain a distance D while folding. His question is pressure. Pressure means? Oh, you can check for pressure. I mean, if there is a case of uplift pressure, maybe you can check this portion for any uplift pressure. Design this bottom accordingly. If there's any case of lateral pressure, I just said you may have to check it over here whether this thickness is sufficient or not. But in most of the cases, if you have provided the same fold in raft all around, I don't see it being a problem as such. Okay, and such a small folds 1.5 to 2 meters, they don't matter much. It's okay to give a fold like this, it will not be a problem. Steel detailing, it will depend. Usually, you may provide, it will depend on what type of folds you can create. You can have a U bar like this, okay? You can have a bar like this. Usually, we don't try and provide, and this can go like this. So, something of this sort you can provide in the reinforcement detailing. One U bar like this, maybe, then one bar maybe like this. These bars, if you are able, you can take them inside, or if not, you can just have them single bars and bars, and then these are my bars for the raft. And then whatever is the reinforcement, some reinforcement in this direction also you can provide. Okay. Yeah. Okay. So then we have some questions in our email. So I'll just take them. So one of the questions asked was by Mr. Tosh Agrawal. He is a practicing engineer from Raipur. So what was his question? His question was, where is this question? How to nahi. When do we assign moment release to end of truss at support? Okay, so I think he's asking about the truss support end supports that we may have to provide, whether we need to provide hinge or roller. I guess that is his question. So here we need to understand a few things. If this is your truss, okay, and whatever its shape is, and suppose this is resting on columns. Now the problems are, suppose you were to provide a rigid joint over here. What will happen if you provide rigid joint? You will see failures in these locations in the truss because of the end moments, and these end moments then will be taken as intensified axial tensions and compressions in these regions. Also, you'll find some local moments over here. So you will always see failures over here in these regions. Also, the problem is that because the truss is not a element where we want to have rigidly connected joints, it will be problem. Okay. So then what people do is that people say that I will have a hinge support over here. So what they will say, I will have a hinge, and uh, so hinge means that it is able to not resist any moment. It allows full rotation. Now the problem with having hinge on both sides is that there will be a high amount of thrust created, and then that thrust, horizontal thrust, is to be taken by your cords, and then you will start seeing problems in your cords. So hinge on both sides is also not a great option. Then what people do, they say that we will maintain hinge on one side and we will have roller on the other. So this allows no horizontal thrust to generate, and this will have a this will mean that the effective bending moment diagram will be as you would get for a pure simply sorted beam, and then your truss assembly can be justified. The problem with this is that in such cases, this column then becomes like a cantilever. You understand why? Because there is no lateral support that you are getting over here. You understand? There is no lateral support that you are getting between the truss roller joint, and the column top. It is free to translate. It is free to translate in this direction. Of course, it's not a pure roller. It has some slotted hole connection, so it can freely translate up to a certain point and then stop over there. But the point I'm trying to say is that if you go for a hinge roller assembly, then you have to be very careful about one of the columns which might become cantilever. So you have to provide additional lateral supports to it. How do we provide additional lateral supports? So usually we will provide what are called as plan bracings. We will usually provide what are called as plan bracings at the bottom chord level. So how do we do that? We will usually provide some runners. These runners typically go along the length of the shed, and then in plan view I will, so for example, now I'm going to draw the plan view. So in plan view, suppose I had these columns in plan. Okay, and then I had these trusses in plan. I hope you are understanding. So now I have provided runners which will go along the shed like this. Now because I had provided a roller assembly over here, my column over here is sort of acting as a cantilever because it's not getting any lateral restraint from this truss. So what I'm saying in such a case, okay, I already have a eaves beam over here. These technical terms, I hope you understand. So I'm not explaining them over here. So you have the eaves beam, you have the tie runner at the truss bottom chord level. So over here, now to help my column not become a cantilever, I can add these additional lateral bracings. So maybe at the two eaves level, I can keep on adding lateral bracings. This will help me ensure that my column does not become a cantilever. Okay. So if you are going to go ahead with a pin roller assembly, I would suggest you to go with this type of a detail so that it will ensure that your column does not become a pure cantilever and it gets lateral support from the bracing system. I hope it's clear. And maybe not every, you can provide it at every alternate tie. I mean, after every alternate thing you can provide. So you provide it over here, for example. So if you see this column is tied by this bracing, this column is also tied by this bracing, this this column is of course tied by this bracing. So in this manner you can provide at every alternate span also. I hope the principle of what I said is clear. Okay. So hinge roller you can do in trusses. It is one of the best things to do because that will actually make your truss behave in the manner you wanted it to. But then just be careful about this column which may become cantilever. So then it will be better to have some lateral supports provided with the help of a plan bracing system. Mr. Vinayak is asking, should we model this folded slab where you want to fold it for raft in safe? You could do that. Nobody stops you from doing it. You could model it in safe if you wish to. And maybe over here you can provide edge releases. So because you will not be able to ensure the moment continuity between these two locations, in the slab, in the safe model, you can provide edge releases to this peripheral slab. That means in plan, if this was my raft and here there was a pit for my elevator, and let's say this is the fold that I have created in my actual detailing. In safe model, you can have edge releases provided over here. So have these releases released, moment released for edge released for moments, so that you don't get any moment continuity between this and the sunk raft panel. Okay, is it clear? Okay. So I think these were the set of questions we had for this session. And if there are no more questions, we can end today's session. Any more questions from anyone? Anyone in the live audience? Now we will see you next week, Saturday, same time, and you can post your questions in the Google form, or you can post your questions, write it through an email to us, or you can put your questions in the live YouTube comments also. So I guess that's all. Thank you, and see you in the next session.